my name is Rachel Pratt and I am in the Math 3430 class at the University of Utah, and my final project is going to be on the cover-up method. So this method is can be used as a replacement or an alternative when we are teaching students how to solve for x. So usually we teach students to just do the opposite operation. So we're going to add 2, divide by 4. But with the cover-up method, it's exactly what it sounds like. So the idea is that you cover up your wherever your x is. And so we're going to kind of look at it like this. So we have this unknown number, and we're subtracting 2 to get 6. So in our brains, we're thinking, what number minus 2 will give us 6? So 8 minus 2 will give us 6. So 8 is going to be equal to this unknown box, but we know that this unknown box is equal to 4x. So then our final step is just going to be to cover up this x. And then again, we're going to say 4 times what number will give us 8. And so we're going to think, okay, what number? Obviously 2. So we have our 2. Our 2 is equal to this unknown box. And our unknown box is just equal to a single x. And that's when we know that we have solved the equation. So this is so much more useful than just for when we have a very simple 4x minus 2 or plus or whatever. I found it most useful when we are doing fractions with unknown x's. So our next example, let's say we have like a 4x plus 2 divided by 3 is equal to 2. So instead of just covering up where our x's are, we're going to cover up the entire top part of our function. So we're going to have a number divided by 3 gives us 2. So again, we're going to think, okay, in our mind, we're going to think what divided by 3 will give us 2. And so that box is going to be equal to 6. And then we're going to look and say, okay, that box is equal to square root of 4x plus 2. And then just like our original problem, we're going to look and say we're going to cover up our x. And we're going to say, okay, what number plus 2 it gives us 6. So we know that that number is going to be 4. So then we're going to say, okay, we have 4, which is equal to this box, which is then equal to square root of 4x. So now we're going to cover up everything on the inside of the square root. And we're going to say, okay, the square root of what number is going to give us 4. And so we know that that's 16. And so now we're thinking, okay, now we're going to think 16 is equal to our box, which is then equal to 4x. So now at the final, we're just going to cover up that x, say, okay, what times 4 will give us 16? And so we know that that will be 4. And the only thing left in our box is x. So we know, obviously, when we're done with the problem is when we just have our single x left. So we can use this method when the powers of x are greater than 1. So we can use it for x squared, x to the third, and so on. So another example is we have x squared plus 5 is divided by 2 and equals 15. So now we're going to make it a little more concise. So we're just going to cover up the top, and so we're going to say what times or divided by 2 will give us 15. So we know that's 30. So we have 30 is equal to everything we covered up. And then we're just going to cover up our 2, and we're going to say what number plus 5 gives us 30, 25. And we know that the only number we covered up is this x squared. And then our final step is cover up our x for our x squared and say what number squared will give us 25. And that will give us x is equal to 5. Now there is one downfall that the cover-up method has, and it doesn't do well when there are multiple powers of x within a function. So if we have, for example, x squared plus x, let's say plus 1 is equal to 6. So with the cover-up method, you would cover up all your x's, and then you'd say, okay, what plus 1 will give us 6, which is 5. So we have 5 is equal to x squared plus x. And at this point, we're kind of like, well, do we cover up one? Do we cover up the other? We come to a point where we can no longer just solve anything by covering up. So that's the only downfall to the cover-up method, is it can't help us beyond when there's just one power of x in a function. So that's the cover-up method. I found it very helpful when it came to fractions. It made them a lot quicker, a lot easier to understand. My question is, how practical of a method is this within a normal classroom? Is this a method that should be used as a replacement of the normal, like, opposite, the idea of the opposites when solving for x? Or should this just be used when a student is struggling to understand the concept and they learn it a different way? My other question is having a student learn this method, would it do them any harm later on in their later grades of math classes, where they need to know the key skills learned in the original technique? And if they only know how to do the cover-up method, would that harm them in any way? Yeah, thank you so much for watching.